All right. Hi. I'm Michael Zbyszyński. As you can tell from my accent, I'm here from Goldsmiths. I work over there in that big building with a bunch of pasta on it. And I'm here presenting RapidMix. Just out of curiosity, is there anybody here who did not get to go to Rebecca's keynote yesterday? All right, see me after. Sorry, she spoke a lot about machine learning and about the project that we're working on together. So I'm going to kind of assume that except for those two, you know that stuff. So I'm working on this project, RapidMix, which is a big consortium of collaborating interests, trying to put some stuff together. I am one of these academics that Jean-Baptiste mentioned yesterday, although not entirely so. But this whole consortium, it's a bunch of us at Goldsmiths, folks in Barcelona, IRCAM in France. These are the academic partners. And then on the corporate side, we have audio gaming, Rolly you might have heard of, or Bracktable Plux. So it's an interesting project in that we've got research and academia, and we've got companies that really want to make products, and at the end of it, we want these things in the marketplace, selling like hotcakes, profit at the end. So it's, for me, a really interesting mashup. As I said, I'm currently an academic. A year ago, I was working for a kind of the Microsoft of DAW companies, except maybe not nearly as well respected as a company, but you might have a guess. So I've worked at huge legacy software companies that have been around for 30 years, like Avid. I've worked at startups like Keith McMillan Instruments or SoundHound. And then before that, I was an academic, but I was studying music. So I kind of have a funny number of angles on this problem of academic research versus business. This struck me as somewhat relevant. When I was in academia the first time, I really loved what I was doing, but I got sick of taking things into proof of concept mode and then dropping them. So I wanted to go out into the real world and make some things. And I was really happy to have done that. But as you all know, industry has its own set of problems. Specifically, let's talk about machine learning. Here's a long-winded explanation that doesn't really tell you anything, which is good that Rebecca has already explained it. I would say the basic difference, if I go back on this slide, is the nature of success and solutions. When I was at Avid, if I got to the end of my sprint and said to my Scrum team, hey man, I didn't close out any of my issues this week, but I learned everything there is to know about multi-layer perceptrons, that wasn't going to work, right? What they wanted to hear is, yeah, the feature's working, yeah, it's solid. Whereas here in academia, we can have this conversation about how did you solve it, where's the elegance, where's all of this? So what my job specifically on RapidMix is to drag all of these elegant ideas and implementations out of the research world and out of the experimental music world and drag them into a world where somebody at a small company can stick them in their product and use them. Somebody at a huge company can stick them in a product and use them and actually get stuff done. And that encompasses a whole lot of things. I can remember for some dumb reason I was working with Node at Avid, and every time I did npm install and saw all the dependencies, every single one of those was an email I had to send to our lawyer about the license, how I had researched it, whether we could use it, where we could use it. At some point you just say, forget it, I'm not going to use that library. So I think I'm happily spanning the edge between kind of practical concerns like, yeah, can I include this in my product? And pie in the sky concerns of, hey, is this a great algorithm to do this kind of learning? All right. The question, so after Rebecca's talk, I was starting to think, I think she did a very, very good job of outlining what's good about machine learning. And one of the things that I kind of laughed at when I was applying for this job, machine learning, biosensors, these are things people have been pushing on me since before I started graduate school. I started graduate school at UC Berkeley, and they had a neural network object running in Max. This is the only trace of it I could find on the internet, which is awesome. It's like, no, don't compile this. No, don't email us. And by the way, those links are to Stuff It archives. So when I got to SINMAT in 1994, they had a little object that ran a neural network, and it had a picture of Matisse on it and the heartbeat when it was training. And it was charming, but that whole thing kind of came and went, partially because, I mean, at that time I was running on a computer that didn't have floating point calculation on the hardware. It was software emulated. Things have changed a lot, and I think there is this critical mass around machine learning that this is really going to come into its own. Rapid Mix hopefully is a big part of it, but even without us, there's TensorFlow and Project Magenta, and I have a whole collection of different kind of APIs that I keep seeing a new commercial API around this every so often. So let's just talk about why I think this is cool and what kind of problem you could solve. So this is kind of a problem. I guess since I've already exposed my age, I also grew up in the era of synthesizers with minimal control. My first synth was a Yamaha TX81Z, which was a horrible user interface because you had like a 2x16 LED and display and 3 buttons, and you had just a billion pages. Maybe some of you have lived through that junk. And then the knob came back in fashion, and so we have these great knob-based interfaces, but you interact with them with a mouse, which I always feel like I'm like poking a Moog with a broomstick. I just remember students coming in and saying, "Hey, look at this, wonderful Reason thing," and it's like, wow, this is all the stuff I hated about hardware implemented in software. All right, so this is a problem I think we've all faced, and there are lots of ways to solve this, right? Obviously, we have presets. We might interpolate between presets. We might write a really complicated mapping function. There are solutions. By the way, I don't think that's a bad piece of software. Does anybody recognize this plugin? I think this company is out of business, so I can dish them. Did anybody in this room write this plugin? Good. Okay, so this is this complex mapping problem, and I'll just give you a quick demo. Let's see if this works. Let's try that one. All right, that seems to be coming out of my laptop. Let's see what we can do about that. Output. It is coming out the speakers too? This could become a talk about the precedence effect, but it won't. All right, great. So speakers too, yada yada. All right, so this synth actually is not nearly as knob happy as the other synth, but this is kind of my favorite digital synthesizer where I have a pulse wave and I'm modulating the duty cycle with a sine wave, and I've got a filter on it. So you see there are 4 parameters. And let me remember how this thing works. If I hit randomize, yeah! Oh, that's even better. I didn't see anybody lunge like this, so it's maybe a good volume. All right, so let me associate that sound over here. I'll do another one. Oh, yeah. Let's find a mellow one. There's a mellow one. And I'll hit train. It's definitely loud for me. All right, so now I've got a space. The cool thing is I didn't put any kind of gain control on this synth. But if you see what I'm doing, I've now generated a space where I can go from all of these interesting timbres and interesting spots in the middle that I never ever thought of listening to. I'm just going to restart this and do this one more time quickly because that's what I was hoping for. I'm not the sound engineer here. Is there somebody who controls the gain in this room, or is it just, I guess I can do this one, yeah. No, I'm oh, look at that. Cool, push buttons. All right, so let's try that again. That's awesome. I pretty much have gotten what I wanted out of this presentation now, so the rest is all for you. There's a nice mellow one. This will be a little more clear. So I am putting my mouse into place, and I'm recording that mouse location in conjunction with that set of parameters. So there's a couple. Yeah, stop harassing me. I'll try another one. Oh, yeah. I'll try it. This one is already, I have a good feeling about this one. And I'll stick that one there. And then I hit this train button. And what I'm doing is I'm training a stack of machine learning models. And now, I've got an expressive thing. And I'm embarrassed to tell you how much time I spent in my office doing this. But it was it was a real inflection point in the project where I had been just writing code for days and days and days and days, and all of a sudden it was like, ooh. Okay, so what is going on? Back to the slideshow. Yes, we have a potential other problem, but let me get back to it. So this is the interactive machine learning problem that Rebecca exposed in a number of different paradigms, that I have a synth. It can make a really broad range of timbres. I have a personal idea as a musician which ones I like and which ones I don't like, but trying to write an exploratory space where I can play with those timbres, that's a hard mathematical problem, right? I mean, but what I was just able to do is teach that synth very quickly through 4 examples in space. I like this, I like this, I like this, I like this. Train, there I have my thing. And this is cool for a bunch of reasons. As just to summarize Rebecca's points, it's all about my musical intuition. So I'm like right there in my flow state. And I think that's kind of why I like playing with it, because I'm not backing out and saying like, oh, should that be a logarithmic? Or, it's all in my flow state. It's all in my intuition. And it's me acting as a user, essentially programming this interface without having any expert knowledge at all, apart from knowing that there's a mouse and deciding that I like something. And so this is a paradigm that is described as interactive machine learning. And I think that's the big thing about what we're doing that might be surprising. I believe that when I came in and thought, I'm going to be working on machine learning, the first thing I think of is some huge problem. I worked at this company, SoundHound, which you might have heard of. Their app works like Shazam. Now that I don't work for them, I can define them by their competitor. You press the button, it tells you what music you're listening to. And this is a classic big data problem, right? We had all the music, so that's tens of millions of sound samples, and you have to find something. And we did machine learning stuff. I remember actually my first week, the girl in the queue on the other side, her computer burst into flames because she had 6 GPUs and was running a huge training set. But that, yeah, if you're going to stick 6 GPUs in a computer, you got to think about cooling. But that's what I thought of as machine learning. We're going to teach a computer to play Go. We're going to take a huge data set. We're going to run it, for days and days and days on the fastest processors we can get, and then we'll come up with something, and then we'll use it to get one answer to, what am I listening to? All right. when I got to this project, I realized that we'd flipped the script in this interactive world where what we're doing is taking often very sparse data sets, a few examples, training really quickly. I mean, I didn't even point out how long it took to train because it just happened. Training really quickly and coming up with a rich space of possibilities, a generative space. So we're taking few examples, generating a huge space, rather than huge examples generating a correct answer. And it's so quick that human beings, real users can do it. You can do it on a phone, you can do it on an embedded device, you could do it on a Raspberry Pi, you could do it on, a Bella. And if you don't like the result, you can throw it away and do it again. So this is the big distinction between classical machine learning, is this fast iteration. And I'm not going to talk a whole ton about cross-validation and various optimization techniques and local minima. I'll show you the API. In fact, there's all the machine learning code that was in that example. 100%. So I defined a thing that is a regression model. Actually, Wekinator makes a stack of models, but I defined a thing that's a regression model, and I defined a vector of examples that I'm going to use to train the thing. And then I'm just pulling the mouse position and sticking that into the training vector. And I call the train method using the training data, and I call the process method using an input. Done. So, if you walked out of the keynote yesterday thinking, how can I have all this tasty, tasty machine learning goodness in my product? The answer is that easy. And you don't have to go back to your Scrum team and talk about how much you learned about multi-layer perceptrons, or how many hidden layers, or what activation functions you used on which nodes, or any of that, which is cool. And I'd love to talk to you about it, but you can just get the thing working, and you're done. Let us see what else we have. Oh yeah, demo number 2. So easy a phone could do it. So that was an example of the C++ API. I'll show you another example. Let's see if I remember how this phone works. Where do they keep the bookmarks on this thing? Pardon me a second. The interesting bane of my existence is the amount of context swapping I do in this job. All right. There's nothing visual to see. This is a classification model. I pre-baked in the training data. All right. Right. All right. So I've got a phone. It's got accelerometers. Here's a sample. Here's another sample. Here's both samples. Think about it. And I'm bored with that. Thank you. And what is this magic that you just saw? And it looks like this. Is anybody interested in JavaScript in this place? Or am I going to get tossed out of the Juice Developers Conference for this one? This is the code for that example. It's running on a platform called CodeCircle, which that guy back there, Mick Regression, could answer questions, or that guy too. It's a collaborative coding platform that we're using pedagogically here, but it lets you put stuff into. It lets you put code in HTML here, and you get the website here. Unfortunately, it doesn't detect my computer's accelerometer. But what you might notice. Hello, CodeCircle. Where's my mouse? Aha. What you might notice is that this is exactly the same kind of code. I mean, I have to say var and new and sort of JavaScript-y things, but I'm just making, this time, a classification. I'm making a training set that looks pretty familiar. I'm calling the train method on that, and somewhere up here, when I get the mouse events, or the accelerometer events, I'm calling process. So this is the exact same method. This is all running in the browser on this phone I just went to that. I have it hosted on a website. I just went there and downloaded it. I'm going to hell for that, aren't I? What we've decided to, so going back, thinking about real people in the real world, we want everybody who wants to do machine learning to do it. So we're designing this API in the interest of ease of implementation and breadth of use cases. We've done tons of user research, trying to figure out what people want. So we've got this C++ API that's closer to the metal, and you can put on an embedded processor, and I think appeals maybe towards the dudes in this room a lot more. And actually, the really ugly thing, and then I run it through Inscripton, and I have a JavaScript API. So you can ask me about Inscripton if you like, but I kind of get a weird tick when I talk about it. But so we have tried to bracket everywhere from low-speed CPU, embedded processors that you have to be really efficient, you have to be really direct, to web apps that you want to run on a phone, you want to get it up and going really quickly. Where am I next? I just did that. So yeah, let me back up. I have one more demo, in case you're not convinced. The other reason I think this is the year for machine learning, so I think that in general, users of technology are becoming more and more accustomed to a much more naturalistic kind of interaction than they used to. When Jules was showing his keynote and he was showing these computers that I used in my life, I remember the TRS-80 and all of this kind of computering, whereas a lot of people are living this phone life, and if Google Now pops up directions to home at the time you usually go home from work, you don't really think about it. I think there's a growing sense of expectation of these naturalistic interactions. And also there's, everybody's got sensors out the wazoo now, right? There's this thing with GPS and a compass and a gyroscope and accelerometer. So this is kind of a big sensor use case. I have a picture of this thing that's called a Myo, which is a EMG sensor. It senses muscle activation. We can talk about Internet of Things stuff. We can talk about quantified self stuff. The idea that somebody would wear a Fitbit. I mean, I was living in Silicon Valley, but it seemed pretty normal to me. Everybody is running around looking for, expecting to have the kind of motions and the kind of actions that they do regularly, intuitively translate into behaviors from their technology. Do I have, I'll show you a demo for that too. How am I doing on time? 5 minutes, okay. This is gonna be fast then. This is good because this is the one that I'm least confident in. So let's see if this works. All right, here we go. So this is all the data from this sensor. I have 8 muscle sensors. I have inertial, an IMU. I have all this stuff. And I have the same synthesizer because I love it. Maybe I'll put my hand up here with my palm open and hit record. And then I'll put my hand over here with my palm shut and hit record. See if this works. Ah, that was promising. Okay, so done. And if I hadn't closed all my tabs, I could talk to you about EMGs and Kalman filters and single value decomposition and all kinds of ways I can process this data, but I didn't. I used the same few lines of code. I can show you that thing on Code Circle actually too if you like. I use the same 3 lines of code. Let's try this way, just for variety. I can show you it in open frameworks, I can show you it in JavaScript. It doesn't really, at the end of the day, it doesn't make a lot of difference. But here's that example. Here's that synthesis example. Yep. Do you like it yet? Because I'm going to keep playing it. But if you scroll down, here's the RapidAPI again. It's a regression object. It's a training set. I train. I process. Done and done. So completely simple API. Completely, start from current slide. Completely, I didn't know if you noticed Rick back here. Completely open source. It's on our website right now. You can download the code right now. It's not encumbered. In academia, we like to give you these little licenses that mean you have to open your software up too, which is kind of cool. But no, this doesn't have that license. It's kind of MIT-style license. Use it. Basically, it's use it for whatever you want. Don't call me if it breaks. But in your case, I like you all, so you can call me. But don't tell anybody else. What else can I say? That's kind of my part. As you saw from the beginning slide, we have all these partners. So we all are coming from this project in different directions, and we have all different parts. And slowly, we're kind of taking this toolbox full of interesting machine learning and data and biosensor technologies and sort of cramming them together into an API. So we're at kind of a prototype version that's more crammed together than it was, but not quite as crammed together as I would like it to be. So once this conference is over, I'm going to go back and jump up and down on that for a while. But again, just walk through the technologies. Rebecca showed Wekinator yesterday. Right now with 100% more C++. So Wekinator, in the release version of Wekinator, kind of represents an interesting problem that I've encountered with other software. I worked for Cycling74. I'm a big Max user. Max is a great prototyping environment, but when you go and say, all right, I want to bake this into my product, it's a problem. And Wekinator has some of these challenges if you want to productize it. I actually don't know it's based on the Weka library, which has a license that I would have to read. And that's not what I do. And it's the models come out in a format that you can use, but it isn't anyhow. So I wrote a version that once you've trained your model, it spits out C++ classes that run that particular model. You can't train it, you can't do anything but run it. But so if you, let's see, I hope I don't have any, it's always that wonder if, I've got some horrible curse word somewhere. So that's it. When you save a Wekinator project, there is a file called C++ source, and you'll see things like a neural network implementation. It's actually pretty small. So you can just bake that straight in. As I say, it's the same. That's it. That's the API. It's the same stuff. There's also a thing, a JSON file, which I always have trouble opening JSON files. I guess I could do it like this. Oops, there's code. Right, validate JSON. So it's a JSON file that describes the whole model, which you can open in the JavaScript API. You can open in the C++ API. So if you want to do your development, and both of those APIs also read and write JavaScript. So if you want to do your development in a browser and then switch to an embedded processor, you can do that. You can walk back and forth between all of these places. I'm probably pretty close to running out of time, aren't I? The session is over. All right. I will come up with an uplifting last slide. Right. So, the good news is it's all on our website. If I wasn't here now and I wasn't writing code, I probably would be fixing links on the website because that's still happening. But that's the link to remember. That's my email. And over the next few months, you can enjoy the drama of watching an API come together and take flight.